Okay, so this lesson is really two lessons together. It's 10.1 and 10.3. We're going to be just putting together a handful of skills that we've already learned. So the first thing we're going to talk about is inverses. And inverse functions, remember, they switch the x and the y values. We did that at the very, very beginning of the semester. Remember that because these are called functions, that means they're going to pass the vertical line test. So anywhere you put your pencil, right, you're only going to be touching the line one time, not twice ever. Because we're switching x and y, that's going to, by nature, switch domain and range, which we haven't really talked about yet, but you're going to see the implications of that in this lesson. And that inverse functions and their original functions reflect across the y equals x line. So there's an example here. If we call this blue line f of x, right, if that was the original function, notice that the ordered pairs here, the x and the y values are just changing. I know that's kind of blurry, but you can see the x and y are just switching. And that the inverse itself is reflecting across that y equals x line. That's what this is. And then the inverse, remember, we write with the little negative one. So this is the inverse function of the original. On both of these, when we just talking about that domain and range, for lines, right, these lines both have arrows on them going forever, so the domain is just all real numbers, or you can say negative infinity to positive infinity, either notation. And then the same is going to be true for the range. This is not going to be true when we talk about the other functions we're talking about today. So we're going to be using this idea of inverses to talk about the inverses for quadratic, that's x squared, and cubic, that's x to the third functions. So let's go ahead and look at how those specifically relate. All right, so here we're talking about x squared versus the square root. So these are inverse functions from one another, right? If you want to write that down, that if one function is x squared, then the inverse function is the square root of x. Now, you all know that x squared and square root cancel each other out. So what they've shown here for you is the original graph of x squared, right? That's just your basic parabola. Remember, basic parabolas start at, so we're just going to take some notes. Basic parabolas start at 0, 0, and they have a pattern of 1, 3, 5, 7, all over 1, right? And then the inverse function is here in red. Now the problem is, if we think about our definition for a function, if I try to draw a vertical line for this red parabola here, the problem is it's going to hit twice. So this inverse they have shown is not a function. And you all know from what we've been doing solving polynomials, when you take the square root, you normally have plus and minus, right? This is going to give you that plus on the top, that's the plus part, and the minus on the bottom. Well, the issue is if I take both of those, like I just said, I'm not going to have a function anymore. So by definition, when we do the inverse, we're just going to take the positive part. All right, so we just want the positive part. So this is going to be, I'm just going to write this for your benefit, positive x squared. Notice that it still has a vertex point at 0, 0, because if we switch 0 and 0, still the same. But this time, instead of going up 1 over 1, up 3 over 1, notice that I'm switching that. I'm going up 1 over 1, up 1 over 3. So this time it's 1 over plus 1, 3, 5, 7. And we're only going to go in the positive direction. So when we talk about domain and range, I just want you to see the implications here. Domain for parabolas is going to be all real numbers, because I can go to the left and to the right forever. But range is going to be 0 to infinity. All right, and then if we talk about that for the square root function, remember it's going to switch. So now the domain, think about the x values, are starting at 0 and they're going on forever. And my range is actually a little bit different this time. My range, if I think about the y values, is still starting at 0 and going positive forever. All right, so let's do two examples of graphing and writing equations for these, and then we'll look at the cube root functions. All right, so the only difference here, this is exactly what you all have done before. We just are going to have a different pattern. So inside's opposite, outside's the same. So I know I'm talking about square root here. My vertex is 2, positive 3. And then I just want to see if there's any stretches or compressions, horizontal, vertical, all that. So I have a negative 3 on the outside. First of all, that negative is going to be a reflection vertically, that's up and down. So I'm going to be reflecting across the x-axis. And then the 3, that is a vertical. 3 is going to be a stretch. So vertical is the same. That's 3. That's stretch. And then we just want to remember square root pattern is 1 over, because we flipped it from squared, plus or minus 1, 3, 5, 7. So this vertical stretch right here of 3 is going to affect our rise. So instead of rising 1, I'm going to be rising 3. Okay? So now let's go ahead and graph that. I'm going to plot the vertex here. So that's at 2, 3. I'm reflecting across the x-axis. So this time, since actually I'm multiplying by -3 on the outside, so I'm going to go down 3, 1, 2, 3, and over 1. And then I'm going to do that again, down 3, but this time over 3. And if I had room, I'll just show you one more time so you get the pattern. I'm going to go down 3 and this time over 5. So notice it's just the vertical component that's changing, not the horizontal component. All right, so there's my inverse function. We can label it, I guess we should use g, g -1 of x. And then we want to go ahead and name the domain and range. So I'm just going to be looking, they give you that original function, you can ignore it. I'm just going to be looking domain, looks like it's starting at 2 and going to positive infinity. Range, looks like the lowest number is actually negative infinity. And the highest value the y is going to reach is positive 3. And those are both included, so we're going to use closed brackets there. All right, this is a very similar question, except this time they're asking me to write a function for the graph that's been given. So if I want to write this function, the first thing I want to do is identify the vertex, just like we used to do. So this vertex is going to be 1, -1. And then I notice this looks like a square root function to me, which means the normal pattern should be 1 over 1, 3, 5, 7. But this time it looks like they're rising 2 and running 1. And then if I check that again, this is rising 2 and running 3. Yeah, so it's the rise that's different, this rise of 2. So they must be multiplying this top number by 2. So when I go to write my equation, I'm going to write, we can write it like a function, f of x equals, I know that I have a vertical, this multiplied by 2 up here is a vertical stretch. So that's going to be on the outside, so that's 2. And then we're going to do a square root, because that's the type of function this is. On the inside, we're going to do opposite. That's x minus 1. On the outside, we're going to do the same, which is just minus 1. All right, and I'm getting these two. This -1 right here is coming from the x-coordinate of the vertex. The -1 on the outside is coming from the y-coordinate of the vertex. All right, so there's my equation. All right, so now let's talk real quick about the cube root functions. This was the second set that we learned to graph. What I have given you here are not the parent functions. So they're not going to start where we normally do. That's because when they overlap if I showed you the regular parent function of each, they would overlap in a funny way. It gets a little bit difficult to see. So notice again that the function, which is here in orange, and its inverse are still reflecting over that y equals x line. That's a typo on there. That should say y equals x on that dashed line. And then the coordinates are still changing their signs, or sorry, rather like the x and the y coordinates. So now we just want to talk about, remember what the different patterns are and what they are for cube root versus cube itself. All right, so the parent cube function still has a vertex. We call it a vertex even though it's like a weird S, right? Of 0, 0. And this is the one that has the pattern of plus or minus 1 over 7 and 1. And then both of these have domain and range of all real numbers. All right, now if we go ahead and switch to the cube root function, and notice cube root function has a little 3 right here, that's what means cube root. It still is going to have a vertex of 0, 0 in the inverse function, but when we flip the pattern, it's going to be 1 over plus or minus 1, 7. And then the domain and range. Now on this one, we don't have to restrict domain and range to only be part of it, because notice that even this blue line down here, this like navy blue line, that's still a function. So cube root, it doesn't matter how you reflect it, it's still going to be a function. So let's look at an example of graphing and one of writing equations for cube roots. All right, so this time I'm noticing that I have a cube root function. I'm going to start, like always, by naming my vertex. Inside's the opposite, outside's the same. And then I want to identify that 1/2. Since the 1/2 is on the inside, right, I'm shaking my head left and right, so that's going to be a horizontal, which means it's going to flip because I'm saying no. So 2, that's going to end up being a horizontal stretch of 2. Since this is cube root, that means my original pattern is 1 over plus or minus 1 over 7. Now this time I'm doing a horizontal stretch, so that means I'm affecting this bottom, that's the run part, and I'm affecting it by 2. So let's look at when we graph this. We're going to go ahead and plot our vertex at 10, 4. And then we want to do rise 1, but we're going to run 2. So I'm going to rise 1, run 2, and this graph is counting by really weird things. And then I'm going to rise 1, run 14 this time. Just going to land me right here. And then we're going to do the same thing in the other way. We're going to go down 1 and backwards 2, and then down 1 and backwards 14. And it's really hard to see on this. You may need to even make some better comments on your notes. And that's what I mean, just to show yourself that you're rising 1, running 2, and rising 1, running 14. Really hate how your book chooses to graph things sometimes. All right, so there's the answer for this one. And let's look at one just about how to write equations for the cube root function, so you have that in your notes. All right, so on this one, we're going to be writing an equation for the cube root function. So we're going to start like we did before. We want to name the vertex. Your vertex is this turning point in the middle. So on this one, that looks like that's going to give me a vertex of 2, 1. And then I know my normal pattern should be, let's see, up 1 over 1, 7. And so I want to look at what's happening here. It looks like they're still going up 1, but this time instead of going over 1, it looks like they're going over 3. All right, so that means that must be this bottom thing is being multiplied by 3. And since it's the bottom, that's rise over run. So run, that is a horizontal change. That's a horizontal stretch by 3. So if I go to write my equation, I'm going to write f of x equals, nothing vertical is happening, so I can go ahead and write my cube root symbol. The horizontal stretch by 3, remember horizontal is on the inside and that flips, so this is going to be 1/3. And then inside's the opposite, so x minus 2, outside's the same, plus 1. Make sure it looks like the plus 1 is on the outside of your cube root symbol there. And there is the equation for that one.